Our next task is to move the ball in the diagonal, and what we're going to do to get that done is we're going to use a cool method that are associated with recs. So all recs, we can use these special methods, and this one here, what we're going to use is called move. And so when we're here in the while loop, what we want to do here, we have code that's associated with the paddles movement, and now I'm going to go ahead and put here ball movement. And the ball movement is very easy. We could say ball underscore rect is going to be equal to ball underscore rect dot move, and we're going to move it, and the move takes in a how much to move on the x and how much to move on the y. Okay, so how much do we want to move it? Well, we would need a ball speed variable, so let's make a ball speed variable, and let's set it equal to 5 and 5. So let's make the ball speed a tuple, okay, because I believe that move requires a tuple as an argument. So I'll take that in and I'll put in here ball speed, save that. And so what is this move method doing? What it's doing is it is taking the first element in ball speed and it is adding it to the first element in ball rect. And so what is the first element in ball rect? If you remember, it is the x position. So ball speed's first element is 5 and its second element is 5. Okay, so what is its move doing? It's taking 5, the first element in ball speed, adding it to the ball rect's x position. So that is moving. So if the ball is here, it's moving the ball from here to the right, and then it is adding ball speed's second argument or second element to ball rect's second element. And what's ball rect's second element is the y position. So we're adding 5 to the ball rect's current y position. So the ball's moved from here to here on the x, right? And then the ball's moved from here to here on the y. Okay, so when we go down here to blit it, this rect is going to be changed. It's going to be not here anymore. It's going to describe here. And then when we come back into the while loop, it's not going to be here anymore. It's going to be here. And then it's not going to be here anymore. It's going to be here. And so if you can see, the ball is moving downward on a diagonal. Okay, and so let's see if that works. And the reason why I'm saying ball rect is equal to ball rect dot move is because move does not change the value of the rect that is being acted on. Okay, what move does is it takes this y position, adds it to this guy's y, takes this guy's x and adds it to this guy's x, and it returns a new rect with that changed information. Okay, so if I go ahead and leave it like that, ball rect is not going to be affected. Okay, it'll stay the same, and this whole thing will return a new rect with that changed x and the changed y, the incremented x and the incremented y. So what we need to do is we need to say, okay, that original rect that we want to change, let's say rect is equal to the return value of the move, right? So move is going to return this ball rect with its x incremented and its y incremented by ball speed, and then we're going to save it in ball rect. And so why is that? So that we can split it at a different location every time we come into the while loop. Okay, we'll split it 5 spaces to the right and 5 spaces down, or 5 pixels to the right, 5 pixels down. And then the next time we come into the while loop, we'll do this again, which will move the rect 5 spaces to the right, 5 spaces down, and we split the ball's rect. We split the ball surface to that new location further down and further to the right. So let's go ahead and see if this works. And let's see, stop, run. You see that? So the ball is moving off the screen. It's going off into negative. It's going off the screen and continuing in that direction. We'll fix that in the next couple of videos.